Welcome to the next lesson in the module on classes in Java. It's time for us to get started building our own class, now that you have begun building your object-oriented vocabulary and learned more about the Java string class. After completing this lesson, you will understand how to employ the proper syntax for writing a class. You will also know how to instantiate objects from that class file and enhance your knowledge of object-oriented vocabulary by recognizing key terms like state, field, and instance variable, and by knowing how these terms apply to classes and objects. Finally, you'll be able to distinguish between three key roles: class author, client developer, and the end user, and be able to make design decisions based on your current task. This lesson will be greatly enhanced if you open up Android Studio and follow along to create the class with me. Be sure to download the files and pause the lesson when I tell you, so that you can modify the code and run it for yourself. Actually seeing the results and problems that can arise when working with class files will stick with you when you begin to work on your own programs. For this lesson, I encourage you to download the project that accompanies this video and follow along using Android Studio. I will explain more about these files as we go along. You will be making changes to these files as well. Recall that an object is made up of both state and behavior. In this lesson, we will be building the account class. To keep it simple, our account will contain a name, account number, and balance. The behaviors will consist of balance inquiry, deposit, and withdrawal. When we begin working on the account Java file, we are building the class, the template from which the objects themselves will be constructed. Very often the terms class and object are used interchangeably, but keep in mind the difference. The class is the blueprint. The object is the instance of the class, the realization of that blueprint. Let's start by looking at the syntax for building the instance variables of the class file. The data portion of the class is sometimes called the state because it describes the object, its current condition. Each piece of data is called a field or instance variable, and you can see how together these fields describe the object. Move to the account file, that's the class file. We will create three instance variables: a string, an int, and a double. Notice these variables are not created inside any particular method, as we've done in the past. And there is no main module to start with. Keep in mind we are creating a class file. It won't execute on its own. It will contain the information necessary to create account objects in other files that may wish to use them. Now let's look at the behavior of the class, the methods needed to interact with the account class. Start with display balance and deposit. In each case, these methods will need to use data stored in the instance variables. Don't redefine these variables, simply refer to them in your method. Because they are part of the same class, the methods can see these fields. Pause this video if you need to, and write these two methods in the account file. Your account file should look something like this, with fields or instance variables at the beginning of the file, not contained within any method. Then the methods or behaviors of the class. Let's think a bit about the withdrawal method. At first glance, it should probably be written a lot like deposit. Take the double parameter and modify the current balance. But there could be problems. We need to check and be sure there are sufficient funds for the withdrawal. That's easy enough. But now we have created two possible outcomes for a withdrawal. Either the balance will be modified or the withdrawal will be rejected. This information needs to be provided to the user. Your first response might be an output statement of either the new balance or something like insufficient funds. But step back and consider class and client programs. As the author of the class, you should aim to make your objects useful, but also general, so that they can be used again in many different client files. This very simple account class, for example, could be beefed up for security and used by a bank, or added onto and used by a game to keep track of online credits, or it could become part of another class and used by, say, a hotel. Most importantly, we need to think of users of the class as other programmers. This is somewhat different from the point of view of the client program author. When writing the client program, which we will do later in this lesson, we use the class and think of users as people who know nothing about the program and how it was created or how it actually works. Right now, we are the author of the class. And yes, in both cases, we are employing abstraction. Today, you are the author of both files, so we will need to consider each point of view. What does all of this have to do with our withdrawal method? Well, we were trying to decide what kind of feedback the class file should supply to other client programs. What would other programmers need to know? A Boolean return value is a good choice. One programmer may use the Boolean value to generate one or two screens with messages and other options for their users. Another programmer may use the Boolean value to penalize the game player for attempting to make a withdrawal without sufficient game credits. But you can see that we should leave user feedback to the author of the client program. Pause this lesson now and write a withdrawal method for your account class file. Here is my completed account class file so far. You can't run this file. We'll need a client file to do that. Let's make sure you understand the difference between all of the components we are working with. We just finished working with account.java. That is the class file, the blueprint. We're now going to look at the syntax in the account client program. This is a program that will use our class. The client program will instantiate or create several account objects by calling on the account.java class file. Pause this lesson and run the account client file in Android Studio. We now have a good class file and a client file that uses the class, but we need to make a few more improvements. Notice how the clients, outside programs, have direct access to instance variables of this class. This is a bad practice. Most, if not all, instance variables of a class should be labeled as private and only accessible to the object itself. At first glance, this might seem to create problems, but it is a sound practice. Contrary to what you may think, you don't have direct access to your own balance at your bank. You may make deposits, withdrawals, transfers, and balance inquiries, but you do this through methods that check for sufficient funds, possibly check some account holder information for security reasons, checking that, in fact, currency or a valid check accompanies a deposit request. Once again, you are a player in the game of abstraction. If you, or someone less scrupulous than you, did have access to their bank balance, they may change their balance whenever they feel like it, and that's no way to run a bank. By making instance variables private, you are protecting your data. Not in the sense of foolproof security, but that other programmers, those writing clients programs, for example, will need to think about how to access this data. They will need to make design decisions. And many will then add a layer of real security, such as passwords or encryptions. By not allowing instance variables to be accessed directly, you control how data will be modified and accessed through well-designed methods in your class. In the case of our account class, that means adding some sort of check before a withdrawal is allowed. So what did we learn from all this? Instance variables, and even methods that are only used by the class itself, should be private. Pause this lesson. Declare all of the account fields as private, and then run the account client program again. Trouble, right? Now that we are protecting access to our fields by using private, code like this, found in the account program, won't work anymore. In our next lesson, we will further improve our class file by adding methods that allow careful access to field variables, and we will learn about constructors, methods that build our objects. Now that you've completed this lesson, You should understand the proper syntax for writing your own class file and know how to use it to create objects that are instantiated in a client program. You should also have enhanced your knowledge of object-oriented vocabulary by learning concepts such as state, field, and instance variable. Finally, by distinguishing between the roles of class designer and client program designer, you should be able to produce classes that can be reused to solve problems in a range of different contexts. As I'm sure you've noticed, we've also broken our programs by using the keyword private and rendering our client program unusable. Therefore, if you'd like to work on your program some more before you return to the next lesson, open up Android Studio and just remove the private keyword from the fields so your client program will compile and run. You can also add method calls and modify data stored in the fields. Be sure to replace the private modifiers and save your files before starting the next lesson. We will return to these files and continue improving them in upcoming lessons.